Hey, how are you?
Good, Joel. How are you doing?
I'm good.
Okay, so we're going to go over imaginary numbers.
Yes.
You have some problems?
So, I actually, yesterday we were gonna have problems. So, if you had problems that you want, like, on your own, that's fine. I mean, I understand them.
Okay.
Um,
You say we ran out of the problems to do, so you don't have any more?
yeah, I did them all. We did them all. I think I'm okay with them. I mean, I spent a little bit more time, and,
There's really only so
I,
much you can do with imaginary numbers. You can add them, which
right,
is easy. You can subtract them easy. Multiplying them, you just FOIL them.
right,
The key thing is knowing that I squared is equal to -1.
right.
And the key thing is also knowing that it repeats every 4. In other words, I to the 5th is the same as I to the 6th is the same as I squared, and so forth and so on.
Mm-hmm.
Um, Let me make up a problem for you. Four minus 2I.
So we have to do it by the opposite of
Yeah,
the
this
denominator. So it would
this
be,
this is not really a division problem. It's
right, so, um,
called the conjugate. I'm going to multiply it by the conjugate over the conjugate.
right.
So what's the conjugate of 4 minus 2I?
It is 4 plus 2i.
And we use the denominator because that's where we're trying to get rid of the I.
Right.
In other words, this is not a division problem. It's do whatever we have to do to get rid of I in the denominator.
Right.
So what's the denominator become?
1, or wait, sorry. Denominator becomes, if we multiply it across, it would be 8,
16?
or 16, sorry. For some
Well,
reason,
actually, it depends on what you're doing. Yeah, I shouldn't have said that because there is a minus 8I, but there's also a plus 8I.
right. So it'd be 16 on bottom, and on top it would be
No.
8, oh, 16 on top because we're
Hold
cross
on.
multiplying.
Hold on. Do this. Let's FOIL this. Okay, FOIL it.
So it'd be 16 plus 8, or wait, 16 plus 8i minus 8i, no, but that cancels out. Minus 8i, and the negative 2i and the negative 2i just equals 0, so there's no
No,
I.
we're multiplying. Minus 2I times a plus 2I does not
So
equal 0.
negative 4i.
Minus 4I squared.
Mm-hmm.
Okay, so, and I squared is what?
1, negative 1.
So we have 16 minus 4 times a negative 1. So what's the denominator?
Uh, 16 plus 4,
Okay.
20.
Now, what's the numerator?
So I have to FOIL it again.
Uh-huh.
So it'd be,
Do it step by step, and I'll read. I'll write it as you read.
okay, it would be 8 plus 4i minus 6i.
Hold on. Where are you getting minus 6i from?
The 3i. Oh, sorry, not minus. It would be plus 6i.
Okay, hold on. When you FOIL it, it's always best to do it in the same order every time.
Okay.
Okay? The F stands for first, 2 times F4. The O stands for outside, 2 times 2i. The I stands for inside, so let's do the inside next. What's 3i times 4?
12i.
Now the last. What is the last?
The last one is a 3i plus times 2i, so it'd be 6i squared.
Now simplify that.
8 plus 16i plus 6i squared, which then turns into 6 times negative 1. So it'd be negative 6.
Okay, so what's the final result?
So it'd be 2 plus 16i.
Over 20. Because we had a 20 in the denominator.
Yep, right.
Okay, and then that's okay unless they want it in A plus BI format. If they want it in A plus BI format, we don't have that yet. What do we need?
Right.
What do we need to do to this to put it in A plus BI format? There's the real part.
Oh, we would put it, it would be 2 over 20 plus 2 over 16. No, sorry, 2 over 20 plus 16i over 20.
Okay, got to reduce everything. You don't ever want to leave an answer as 2 over 20.
Right. So it would be
That's
1/10
1/10 plus 4/5 I. It's not 4i over 5, it's 4/5 I. In other words, standard format is A plus BI. This is a real number, that's a real coefficient. So always keep it together and leave the I outside of it.
All right.
Okay? Okay, what else do you need to go over for your test? When is your test? Is it tomorrow?
Yes.
Okay.
Yeah, I'm feeling a lot better about the whole logarithmic stuff and this.
Okay, so you're good to go on logs. You're good to go on exponentials. Let me test you. Tell me what this log expression is. That's the exponential expression. Give it to me as a log expression.
Right, let me rephrase it. I think I'm better on working out the log problems.
Okay, well this is real key. You need to be able to switch back and forth between exponential expressions and log expressions.
Yeah.
In other words, you need to know that if y equals b to the x, what's the log expression of that? Of y equal b to the x.
It would be log of base 2.
Well, let's do this one first.
Oh, it would be log base b x equals y.
No. Logarithms are exponents. So at a very minimum, when you go to write the logarithmic expression, do it this way. Remember that logs are exponents, so that has to be true.
Right.
Now I got to figure out where to put the b and where to put the y. Well, the b always goes there. That's easy. The only place left for the y is there. So this is the logarithmic expression of that. They're the same thing. So give me the logarithmic expression of this.
So it would be log base base 2 8 equals 3.
There you go. Okay. Because a lot of times when you're going to solve those logarithmic equations, the only way to solve them is to take the final log expression and turn it into an exponential expression and be able to solve it. So you got to be able to go both ways. If I'd have given you log base 2 of 8 equals 3, you need to be able to, so tell me what this means.
The natural log?
Oh, hold on, no, I'm not done yet. I was.
Oh, okay, sorry.
That's okay. What's that equal to?
0.
What's that equal to?
0.
Can't fool you at all. Okay. What are you going to have on the test besides logs, exponentials, and imaginary numbers?
Let's see here. We have finding like domain and range.
Okay, let's talk about domain.
I guess that's another thing. How do I find the domain range? Like, what is it? Because I know how to do all the graphing and stuff.
I'm about to tell you.
All right.
If I say y equals x, x can be any number on the number line, and y would be the same thing. So the domain for x would be all real numbers. The range for y would be all real numbers. If I say y equals the square root of x, now what is the domain for x? What can x be? Or more precisely, what can't it be?
Anything higher than x?
No. X can't be negative. You can't take the square root of a negative number. So the domain for this function would be x has to be greater than or equal to 0.
Right.
Because you cannot take the square root of a negative number. You can take the square root of 0, you just can't take the square root of a negative number. What's the range? What can y be?
Anything greater than 0.
Exactly. Greater than or equal to 0 also. In other words, it can't be negative either. So
is that what the infinity sides come in as? Like the whole 0 plus infinity or something?
Are you talking about the interval notation where the domain would be represented as 0, infinity?
Mm-hmm.
Yeah, that's interval notation. That's the same thing as x is greater than or equal to 0.
Oh, okay.
Okay? It's just different notation.
All right.
If you use interval notation, I'd be happy to switch to that. But let's go one step further. How do we solve for the domain there? You take whatever's inside the square root sign. What does that have to be? The whole thing?
Excellent. It'd have to be anything greater than -1.
Well, no. In other words, you start. Don't try to do the whole thing at once. Just start by taking what's inside the radical and let it greater than or equal to 0. We know that that has to be true. No matter what x is, x minus 1 has to be greater than or equal to 0. Yeah. And then we solve this inequality. That means x has to be greater than or equal to 1. Or in interval notation, it would be 1, infinity. And actually, I made a mistake on the other one. Since it could be equal to 0, on the other one, I need a bracket for the interval notation.
Okay.
So this is the domain. Okay? Range is still the same. Range is greater than or equal to 0. It hasn't changed. Y still has to be greater than or equal to 0. And it certainly can be 0. If x is 1, y is 0. Okay, so I'm only going to talk about the functions where you're going to have a restricted range. In other words, if we look at a function like this, there's no restriction here. X can be anything you want. There might be a restriction on the range because this is a parabola. Parabolas plot like this, so the range is going to be restricted on the downside by that number right there.
Okay.
So there is a restriction on range in some functions, like quadratics. But let's go back and talk about domain, because actually domain is the easiest thing to figure out. Now, tell me this, domain. Well, it's inside of a radical, so what would that make it?
Positive.
So I could say x is greater than or equal to 0, but I'm dividing by this thing. So can it be equal to 0?
No.
No, it's got to be x is greater than 0 only. That's the domain.
Right.
In other words, you have to look for how x is restricted. And sometimes it's multiple restricted. In this case, it's multiple restriction. Now, the last one that has a severe restriction on it are logarithmic functions. What's the domain on that? What can x be? What's the domain on x?
I don't know.
When you're taking logs of numbers, you can only take logs of positive numbers. You also cannot take the log of 0. So the domain on x is it has to be positive. It has to be greater than 0.
Right.
What's the range on this function? Before you answer, let me graph it for you. Notice that from that graph, the domain is only positive. It's only greater than 0. It never goes to the left of the y-axis. What's the range from the graph?
0.
The range is what can y be? This is the y-axis.
Anything positive of 0.
Look at that function that I've drawn, the curved red line.
Yeah.
What can that be? Can it be negative infinity?
No.
Well, yes, it can. It keeps going. In other words, it doesn't stop there. It's asymptotic to the y-axis. So it goes from negative infinity to positive infinity. So the range is all numbers. And you can tell that by looking at the graph. In other words, if you look at any graph, you can read the domain and the range off of it. You just have to look at it. Okay, let me give you another example. What's the domain of this function? This is y equals sine x. This is the x-axis. This is the y-axis. What's the domain? Read right from the graph.
-1. Or 0.
Domain has to do with the x coordinate, not the y. It has to do with the x possibilities. From this graph...
So it's negative infinity and positive infinity.
There you go. We can see that. It doesn't end on the left, and it doesn't end on the right. I may have stopped it there, but it doesn't end. It keeps going. What's the range from the graph?
-1, 1.
With brackets, incidentally.
Right.
Because it can be equal to 1, and it can be equal to -1. It's equal to 1 right there. It's equal to -1 right there. So you understand now why you can always read the domain and range from a graph? Let me give you one more. We're going to take the hyperbolic function, which looks like this. This is y equal 1 over x. What's the domain? Read from the graph.
It would be
Where does it start? On the far left.
-infinity.
Okay.
It ends at +infinity.
Can it cross this y-axis? Does it cross this
Oh,
y-axis?
no. So it'd be -infinity to 0.
And it can't be 0, because that would be
Right,
division by 0.
Right.
Union with
0, +infinity.
what's the range? Read from the graph.
It'd be -infinity, 0, union with 0, +infinity.
There you go. That's what domain and range means. One last test. The domain on that.
Let's see why.
Okay, use the methodology I taught you. What's the very next step you want to write?
It would be x minus 1. No, whoa.
X squared minus 1. That's what's inside the radical.
1.
Has to be what?
Is greater than or equal to 0.
Okay. Now solve that, because we're not done. Just by stating that doesn't solve it. The domain is whatever x can be. So what's the next step in this solving this inequality?
We have to put a -1 on the other side, so it would be x is greater than 1.
But it's x squared. Okay.
X squared is greater than or equal to 1.
So what's the next line?
It would be square root, so it would be x is greater than or equal to the square root of 1, or 1 squared.
How about
Just
x
1.
is greater than or equal to plus or minus the square root of 1?
Oh, okay.
It's always that when you're solving an equation. But x being greater than the square root of 1, I mean, x has to be either greater than 1 or it has to be greater than, actually, I shouldn't have written it like that. Let's talk about this. Not everybody is aware of this. When you have x squared is greater than or equal to 1, let's make it a 4, just because it's going to be more understandable. That means that either x is greater than or equal to 2 or x is less than or equal to minus 2. So that logic right there is very important.
Okay.
It's kind of like when you do it really is x is something plus or minus 2. The problem is that when it's minus, you need to switch you've basically divided the inequality by a negative number, and you need to switch the sign and the direction.
Yeah.
So that's how x squared being greater than or equal to 4 switches to this. Notice this makes sense. If x is 3, then certainly 9 is greater than or equal to 4. If x is minus 3, when we square it, it becomes 9. So 9 is still greater than or equal to 4. So what is the domain and interval notation? Take what I've circled there and give it to me in interval notation.
So it would be negative infinity, comma 2.
No?
Negative 2.
Right? In other words, always go from left to right.
Right, and then it'd be
Parentheses or bracket?
Bracket. It's going to be equal to. And then it'd be bracket, or union with bracket 2, comma, positive infinity.
There you go. And then infinities always have parentheses, never brackets.
Right. Right.
And that's probably as hard of one as you're going to get, where they put a more complicated function inside the radical. But all you do is take whatever, no matter how complicated that is, just take it out and set it equal greater than or equal to 0 and then solve it.
All right, yeah.
Okay?
Oh, that makes sense now. Yeah, I totally get that. And all it is you have to look at it so you can understand it. All right.
Yeah.
All right.
Range is actually a lot harder. Range is usually much harder to figure out than domain. But
Yeah. Right.
depends on the complexity of the problem. So, all right. Got any other besides imaginary numbers and domain and range and logarithms and exponential expressions? Is that pretty much going to cover your test?
Pretty much. I mean, other than finding out zeros, just the zeros of stuff.
Okay, when you find out the zeros of stuff, you said,
Right.
what are the zeros of that? Well, in order to find the zeros out, I have to set it equal to 0 and then solve it. That's all finding the zeros means.
That's it. So here, for example, one of them is 6x squared minus x minus 15. So we'd have to equal that to 0.
That's the zeros. Because
And
this
15.
this is equal to y. So we're saying that when y is 0, well, that happens on the x-intercepts, right?
Right.
In other words, no matter what the function looks like, when we set this equal to 0, we're setting y equal to 0. That's
Right.
the zeros, because the zeros are where this thing crosses. The zeros are there and there. Not because I put zeros there, but because that's where it crosses the x-axis. Okay?
Right.
And that's always where y is 0. So to solve this, we factor it. Is this a real problem, or is this one you made up?
No, this is actually one that is on here.
Okay, I usually try the two nearest factors to start. This one has some possibilities. In other words, some different combinations. It could be 6x and x, could be 3x and 2x. 15, most likely going to be 5 and 3. So we know it's plus minus, based on that minus, or it could be minus plus. Because these coefficients are different, it's going to matter. Okay, so I'm just going to start randomly trying them. I'm going to try 5 and 3. Does that work? Well, it gives me plus 10x minus 9x. It gives me a plus x in the middle. Well, what does that mean? It means that it works that way.
Right.
And so even though I was completely on trial and error, I got it the second try, And that's because the first try almost got it.
Right.
But that is correct there. So now, we're still not done. We haven't found the zeros yet. Now what's the last step?
Is to go through and multiply together?
Two numbers can only be multiplied and equal to 0 if one of them is equal to 0. That's the
So
key.
replace x for 0?
No. Listen to what I said. Two numbers, that's one number. That's another number. They are multiplied together to produce 0. That means one of these has to be 0. That's the only way you can get 0 when you multiply two numbers, is if one of them is 0. So how do we solve this from here?
Plug in 0 on one of the sides?
We set that equal to 0. 3x minus 5 has to be 0, right? That's what we just said.
Right.
Or
Right.
2x plus 3 has to equal 0. And we just solve each of these. X is equal to 5/3, there's one 0. X is equal to minus 3/2, there's the other 0. So those are my zeros.
Oh, okay. So all of these, because I see further on, there's like the very last one in all these questions, it says like it's really long and it goes into like cubed and then power of 4 and stuff. So I just have to go through and do each one because that's how many times that it goes past.
Well, the ones that are cubics and powers of 4 are very special ones. We should have been talking about that before now. They're harder. There's special techniques you have to use. You can't use the technique we just used. This is a quadratic. A quadratic always is the product of two things. So you can always find the zeros on a quadratic. It may not factor nicely like this, but then you can use the quadratic formula. Cubics, which is x to the thirds, and quartics, x to the fourths, are in a world of their own. That's the difference between college algebra and algebra 1.
Okay.
So if we're only doing a half-hour session tonight, we don't have time to talk about those.
Yeah, I know. All right.
Okay?
No, but yeah, that makes sense. All right, so yeah, I understand that. I think I'll be able to work out the other ones because
Usually, if they're giving you cubics, you can solve them by grouping. And if they're giving you quartics, you can solve them by substitution and turning them into quadratics.
okay, yeah, I remember how to do that. Yeah. Okay.
All right.
All right.
Okay, well, good luck on your test.
Thank you very much.
All right, Joel. Talk
All
to you
right.
later.
Thank you very much. I'll let you know how it goes.
Good. Thank you. Bye-bye.
All right. Bye.